Welcome to Engineering Simple, and welcome to Limits Part 4. So I'll continue evaluating limits. So if I have two, so I'm trying to find the limit for 2 times x plus 2 divided by x plus 1 as x approaches 1. So obviously I can plug in 1 directly and see what I get. But like always, it's always to be consistent, just write out the equation and then always kind of try to make some observations, so like in this case I see that I can factor 2, so factor 2 times x plus 1 divided by x plus 1, so this cancel out, so I just get 2, and I can verify if this is correct or not. So if I just go back to 2x plus 2 divided by x plus 1, and I replace x with 1, so 2 times 1 plus 2 divided by 1 plus 1. Basically, I just replaced x with 1. 2 times 1 is 2, then plus 2. 1 plus 1 is 2, and I get 2 plus 2 is 4, divided by 2 is 2, basically. So I get the same number. But it's good to get in the habit of kind of factoring, something that's common to numerator and denominator. Then you can cancel them out, because we'll see this is kind of basic, but it gives you the idea and kind of explains the concept. But as the limits get complicated, it's very important to kind of go through this exercise of finding a factor that's very common to both sides. So the same thing here. So the first step is just write the entire thing. So 6x minus 2 divided by 3x minus 1. So here I can factor, I see that 2 is common, so 2 times 3x minus 1 divided by 3x minus 1. So these cancel out, so I end up with 2 basically. And again, I could have just went to basically took this equation here and just replaced x with 0. So 6 times 0 minus 2. Then I have 3 times 0 minus 1. 6 times 0 is just 0 minus 2. 3 times 0 is just 0 minus 1. 0 minus 2 is just minus 2. 0 minus 1 is minus 1. So negative, negative, they cancel out. 2 divided by 1 is just 2. The same. So I got the same number. But again, this happened to be simple, but it's just to prove the concept, or kind of explain the concept of evaluating this limit. But as the limits get complicated, it's very important to figure out how to simplify them before you can plug in the numbers. So like always write out the entire thing. 2x plus 2. Again, the top one, this x minus 2, x squared minus 1 is the same as x squared minus 1 squared, because 1 squared is just 1. And notice, I would recommend watching the video on remarkable identities. So a squared minus b squared, which is basically the same as this here, is the same as a minus b times a plus b. So I can write this, my a in this case is x and my b is 1. So x minus 1 times x plus 1. So it's very important to know those identities. In this I see that 2 is common, so 2 times x plus 1. Notice this is common, so I can get rid of it. Then I end up with x minus 1 divided by 2. Then I'll replace x with minus 1, basically. So x replaced with minus 1. So minus 1 divided by 2. Minus 1 is minus 2 divided by 2, which is minus 1. So if you notice here, if I went back and just plugged the number, let's try it and see what we get. 2x plus 2. So instead of going through this process here and taking advantage of this identity, I'm just going to go back and just plug, instead of x, put in the value negative 1 squared, basically minus 1, then 2 times negative 1 plus 2. So negative 1 squared, just 1 minus 1, divided by 2 times negative 1, which is minus 2 plus 2. So notice 1 minus 1 is just 0, minus 2 plus 2 is 0. Well, this does not make sense. So if I went through this process like I did in part 1 of evaluating limits, if I just went through, this is what I did basically in part 1, I just plugged the number. If I hit 0 divided by 0, then I have to go through this process here of finding a common factor, then try to simplify. So in this case, I cannot just plug in the numbers, so I can't go this route. That's why I have to go through this process here. So in this case, that's where knowing those identities is very important. So again, we can just write the entire thing. X squared plus 4x plus 4 divided by x plus 2. Again, I see here a squared, and I see this going to be squared, and I see here. So this kind of gives me a hint that it looks like the identity a squared plus 2. So there's a 2 here, 2 times a times b plus b squared, which is the same as a plus b quantity squared. So let me write this. I want to write this here the same as this here. So x is already squared, plus I know there is a 2 times, so 2 times something would give me 4x, so it's times 2x, plus 4, if I square something would give me 4, that's 2, plus x plus 2. So I know this is in the form of a squared plus 2 times a times b plus b squared, which is a plus b squared. My a is x and my b is 2. So I can just write x plus 2 squared. So again, that's where those remarkable identities come very handy. So x plus 2 quantity squared is the same as x plus 2 times x plus 2 divided by x plus 2. So I can simplify. So this is just x plus 2. Then just replace x with 1, 3. Notice in this case, I had to evaluate this limit here as x approaches 1. What if x was approaching -2? So if I go the route, I showed in part 1, so I'll do basically x squared plus 4x plus 4 divided by x plus 2. And I'll just replace x with -2. So -2 squared is just 4 plus 4 times -2 is -8 plus 4 divided by x plus 2, replace x with -2. -2 plus 2 would be -2 plus 2 is 0. So that's a problem. 4 plus 4 is 8, minus 8 is 0. So in this case, if x was approaching -2, I cannot just plug the number. Definitely, I would have to simplify and take advantage of this identity. So those identities are very, very critical to know. So here's another one. So I'll just write the entire thing like always, x plus 1. So what I'm trying to show here is how to manipulate both sides, and so that you can simplify later. So if I notice here, this here is another identity in the form of a squared minus 2 times a times b. So notice there is 2 here, plus b squared, which is the same as a minus b squared. So I'm going to try to write this here in the form of this. So x is already squared, so x squared minus, so I have a 2 because I know there's a 2 here. So 2 times something would give me 2x, so times 1 times x basically, plus 1 squared is just 1, so minus x plus 1. So notice my a is x and my b is 1, so I can take advantage of that identity. So it's x minus 1 squared. And notice here minus, I can factor, minus, basically it's like -1 times. So minus x minus 1, because minus times x is just minus x. Minus times minus 1 is just plus 1. And again, this here, x minus 1 quantity squared, I can write it as x minus 1 times x minus 1. And I have minus x minus 1. So I know this is the same as this. I can cancel. Then I end up with x minus 1. And I have minus, it's just minus 1 basically. And again, I have to multiply top and bottom by -1 to get rid of this negative sign here. Sorry, minus 1 here times minus 1. So minus 1 times x minus 1. So minus 1 times x is minus x. Minus 1 times minus 1 is plus 1. Then I have minus 1 times minus 1 is just 1. So minus x plus 1 divided by 1 is just minus x plus 1. Replace x with minus 2. So it's minus 2 plus 1, which is, so minus times minus 2 is just 2, plus 1 is 3. Why did I have to go through this factorization here? Well, what if this here, instead of x approaching -2, what if it was approaching 1, x approaching 1? So if you just quickly go here, replace x with 1, so minus times 1 is -1 plus 1 is 0. And you know you can't divide by 0. In that case, you cannot evaluate this limit just by plugging the number. You have to go through and recognize that this can be written in the form of this identity. Then you can kind of simplify, and that's how you would basically evaluate the limit. So those identities are very important. So I'll just write out this plus 1 minus x minus 1. Notice here x3 plus 1 is the same as, x cubed plus 1 cubed, because 1 cubed is just 1. And notice this is another identity. It's the same as a cubed plus b cubed, which is equal to a plus b times a squared minus ab plus b squared. So it's another identity. So basically 1 is just 1 cubed. So again, I can take advantage of this. So my a is x and my b is 1. So basically I'm just going to apply this identity. X squared minus x times 1 is just minus x, plus 1 squared is just 1. And notice here I can factor -1. Basically, that's what I'm doing here. X plus 1. Because minus 1 times x is minus x, minus 1 times plus 1 is minus 1. So then I know this is the same as this, so I can reduce it to this x squared minus x plus 1 minus 1. And I can multiply top and bottom basically by -1, the entire thing. Basically that's what I'm doing here. So -1 times -1 is just 1. Then I just end up with -1 times the entire thing, then basically change the signs. If you see negative, you change it to positive. If you don't see anything, you just change it to minus. Minus x squared plus x minus 1, basically. So then I just plug in the number, so minus, instead of x, minus 2 squared plus minus 2 minus 1. So minus 2 squared is just 4, plus minus 2 is just minus 2, minus 1, minus 4, minus 2 is minus 6, minus 1, minus 7. So here's another identity basically. So if you notice a 8 times x cubed minus 1, because I know 2 to the power 3 is just 8, x cubed minus 1 cubed just 1, then I can write this as 2x cubed minus 1 cubed, and I can take advantage of the identity a cubed minus b cubed is the same as a minus b times a squared plus a times b plus b squared. So I would recommend watching the video on identities or remarkable identities. So in this case, my a is 2x and my b is 1 basically. So I can go ahead and do 2x minus 1 times 2x squared, which is 4 squared, plus 2x times 1, which is 2x, plus 1 squared, which is just 1. Again, minus, so I see 2x minus 1, so I need to change this to be the same, just multiply by negative sign. So minus times 2x is just minus 2x, minus times minus 1 is just plus 1. So then I can get rid of this. So I end up with 4x squared plus 2x plus 1 divided by negative 1. And again, I'll multiply both sides by negative 1 because we don't like to see negative sign at the denominator. So plus 2x plus 1, negative 1 times negative 1. So negative 1 times negative 1 is just 1. So negative 1 times 4x is negative 4x squared. And negative 1 times plus 2x is just negative 2x. Negative 1 times plus 1 is just negative 1. So this is just negative 4x squared minus 2x minus 1. Then I'm just going to plug in the numbers. So negative 4 x squared minus 2 squared basically. Replace x with negative 2 because x approaches negative 2. So minus 2 times negative 2 minus 1. So negative 4. Negative 2 squared is just 4. Negative 2 times negative 2 is plus 4, negative 1. So negative 4 times 4 is negative 16 plus 4, negative 1, which is, so negative 16 plus 4 is negative 12, minus 1 is minus 13. So that was it for this video. If you want to watch more videos, you can go to Engineering Simple. Thank you and have a great day.